Hi everyone, welcome to Iron Mind Get the Concept. So what we want to talk about today is organic chemistry. For some students, this poses a problem, while for others it's as simple as a piece of cake. So we're only going to talk about the basics to cater for those when that finds a problem. To understand organic chemistry, we need to understand carbon, because organic chemistry is all about this guy. It's all about carbon. So let's talk about how carbon works. First of all, what we need to understand is that carbon has got a valency of 4, meaning each carbon atom has got 4 electrons in the atomic shell. Alright? Valency means the combining power of an element, which means it can only use 4 electrons to combine with another element. Right? So what we're going to do here, we're going to draw another sister carbon atom, also having 4 electrons in the atom shell, valence electrons, right? So what we're going to do is we're going to try and combine, bond these together. From our grade 10, we know that's covalent bonding, right? So what we do is this carbon atom donates its electron, this carbon atom also donates its electron. If you count their electrons in the outermost shell, they each could have 6. 1, 2, 3, 4, 5. Not 6, but 5. This one the same. For them to reach an outermost shell, which they want, 8 electrons in the outermost shell, all of them will donate 4 that they have. Alright? That's basic 10th grade chemistry. So that one donates it 4. That one donates it 4. And then you wrap them all off because they're donated, right? Then you have something like that. If you count them, 2, 4, 6, 8. So each carbon has got 8 electrons in the atomos shell, so they are satisfied, they're full, right? So now how do we apply this to organic chemistry? That's what we're interested in. This bond, this single pair, right? This single pair of 2 electrons is what is commonly represented or usually represented as this, a single bond. A single bond is the same as 2 paired electrons. So this diagram here can be represented as, which is the same. Alright? Each line represents a pair of electrons. How many are they? 4 pairs, 4 lines. So this is what you usually see in organic chemistry. A line represents a pair of electrons. This is where this comes from. It comes from that. So let's move on further into organic chemistry now. Each of these carbon has got their capacity to bond to another atom. What are we talking about? What do we mean? Let's introduce a hydrogen atom there. Right? Now remember, this is as good as that. So this guy takes his electron, this side, to bond with this hydrogen atom. Okay? And that's gone. And that is as good as this. Now here's an important point to remember. Your understanding organic chemistry and getting things right depends on this. Always, to carbon atom, there must be 4 bonds attached to it. Always. It has to have 4 bonds attached to it because it's got 4 electrons that it uses to bond, okay? Let's count for this guy. 1, 2, 3, 4. So this carbon atom is good. How about this one? 1, 2, 3. And there's a problem. What do? We introduce another hydrogen atom this side. Now remember from the bond that we broke, 1 electron went this side, 1 is remaining. So this electron comes here. Hydrogen donates 1 electron. Hydrogen can always only donate 1 electron because it's got 1 atomos shell electron, okay? And therefore, hydrogen always has got 1 bond attached to it. Alright? So what we have here, we've got again a single bond, which we present by a line. Alright? We're trying to solve his problem. Is it solved? Let's count the bonds. 1, 2, 3, 4. 4 bonds for each of the carbon atoms. So they are both satisfied. Can these carbon atoms be further attached to something else? Yes, they can. Introduce 2 more hydrogens there. This is as good as that. Remember, this goes here, that goes there. There's a bonding, there's a bonding, right? We present this as we're presenting them, single bonds. Then you've got this. I'm sure you can now see what shape we're getting here. This is called an alkene. Alright? It's called an unsaturated hydrocarbon. We'll come to that later. Can these carbons further attach to something else? Yes, they can. We introduce 2 more here, and what we're going to do is we're going to bring this electron there. No, sorry, not there, here. We're going to bring this electron there. Donation from the hydrogens. Then you've got bonds. And you get something like that. Right? This is a dead end for these carbons. They cannot further attach to anything else unless we form, unless we represent these hydrogens with something else. Alright? So, this is what you call a saturated hydrocarbon. We'll talk about these hydrocarbons in future videos, alright? What does the word saturated mean? Simply means full. Look at our carbons. They are all attached to 4 bonds to different elements, which are hydrogen atoms. They cannot further accommodate something in, right? That means they are full, they are saturated. That's why we say alkanes are saturated, or they are full, alright? So that's the basics of organic chemistry. Let's recap the main important points. Always attach 4 bonds to the hydrogen carbon, alright? And make sure they are not more than that, alright? And then you got to know the valencies of your other atoms. So for now, that's enough from us, from the basics of organic chemistry. If you need more of these concepts explained, we've got a new book out. It's called Quick Chemistry. And in there we discuss such kind of matters where we simplify stuff that bothers a lot of students at school. And as Iron Mind Learning Center will also offer online tuition sessions and also one-to-one personals if you would like that. Until you hear more from us, give us a comment if there's any topic that you want to hear about. We'll be happy to help, either in physics, chemistry, or math. So for now, bye-bye from us.